This should be a pretty quick video. Adding and subtracting radicals is a very basic concept if you have understood in the past how to add and subtract with polynomials. It's very similar. All we're going to do is combine like terms, and when we do so, we're going to add or subtract the coefficients. Remember, adding and subtracting is like adding or taking from a pile. One other extra step, though, that we will have to take is that we have to simplify radicals if at all possible. So I have 3 examples here. Let's go ahead and look at the first one. The first one is fairly basic because if you look at each of my radicals, none of those can be simplified. The square root of 5 doesn't have any perfect squares, and the cube root of 5 doesn't have any perfect cubes. So first thing I do is I look at this first set with parentheses here, and I realize that there is not anything to distribute in, which tells me that these parentheses are not necessary. If I look at the back set of parentheses, I technically have a plus sign to distribute in, but remember, distributing a plus doesn't change anything since a positive times a positive remains positive and a positive times a negative remains negative. So I'm just going to go ahead and get rid of all these parentheses. And notice I am not using FOIL, which is a big mistake that I see frequently. And I know not to use FOIL because I only FOIL if multiplying, which would mean my parentheses would have to be right next to one another. From here, I check for my like terms. I have a like term here. I have 2 radical 5, and I have minus 8 radical 5. Remember, the sign belongs to the number. When I put those together, adding the coefficients of 2 and negative 8, I get negative 6 radical 5. And then checking for other like terms, I see I have this like term here, negative 4 cube root 5 and positive 6 cube root 5. Again, I add my coefficient. Negative 4 and positive 6 is going to be positive 2 cube root 5. And so notice that my roots don't change at all because, again, if I have 2 of something and I get, or if I'm in the whole 4 of something and I get 6 more, I have 2 of that same something. That something doesn't change. Let's go ahead and look at examples 2 and 3. We'll start with example 2. So I'm going to go through the same process, but now I notice a couple different things. One of the first things I notice is that this is a subtraction problem, and distributing in a subtract sign does change things. So once again, my first set of parentheses, there was nothing to distribute, so I'm going to go ahead and just leave that as is for the time being. And distributing the minus sign into my back set of parentheses, I get minus square root 27 plus square root 20. Unlike the first one, these radicals can be reduced or simplified. I see 75 has a perfect square of 25 in it, so I'm going to break that into 25 times 3. 30 does not have any perfect squares in it. 27 has a 9 in it. And 20 has a 4 in it. So 25 is going to go ahead and become radical 25 is going to become 5. So I'll have 2, 5, and I know when two things are written right next to each other, it means multiply. So I'm going to have 10 radical 3 minus radical 30. Radical 9 I know will become just 3, so I'm going to have 3 radical 3. And radical 4 will become just 2 radical 5. From here, I check for like terms. I notice that I have 10 radical 3 and I have minus 3 radical 3. Those are going to be like terms, so I'm going to go ahead and say if I have 10 and someone takes 3, I'm left with 7 of them. Of what, you ask? Of radical 3. I don't have any other radical 30s, so I'm just going to leave that. And I don't have any other radical 2s, so I will just leave that. And this will be my most simplified form. That's all I can do on that one. Example 3 would be a great one for you to pause the video and try on your own. All right, now that you've had a chance to try one, let's go ahead and see how you did. So I notice there's nothing to distribute on this one, but there are some radicals that I can reduce. So I'm going to say I have 3 radical 4, radical 5, minus radical 9, radical 5, plus 4. 80 is divisible by 16. Remember, if you were only able to say it was divisible by that 4, that's fine because you could have radical 4, radical 20, and then you would just have to take that radical 20 and simplify it again. you will get the same result as me. So now radical 4 I know will become 2, so I'm going to have 3 times 2 is 6. Radical 5 minus radical 9 will become 3 radical 5 plus radical 6 is going to become 4. So I'll have 4 times 4 is 16 radical 5. I notice that all three of these are like terms since they all have the same radical part. So if I have 6 and take 3, I'll be left with 3. And then I add 16 more to that, and I will have 19 radical 5 for my final reduced answer. So once again, just to review what we talked about, be careful if you have two sets of parentheses, it does not necessarily mean FOIL. If there's a plus, you can just drop parentheses because distributing a plus doesn't change anything. If there is a minus, make sure you distribute that minus sign into all terms. And also always check to see, can I simplify my radicals? Because they may not be like terms to begin with, but after simplifying, I may find that I do have some like terms that I can combine. And then finally, when you're combining those like terms, just make sure you add the coefficients and do not change the radical part.